workpiece number 2. Exercise number 2. 3. Yeah, actually, by right it should be 3. Okay, but anyway, never mind. Okay, you just group 1. Use 2-1. Okay, group 2, 2-2. Group 3, 2-3. Clear? I can use anyone, huh? Then your
okay.
Okay. So you can sit around here. Because your right is very good. So first thing, switch on the power. Okay, switch on the power. Follow the diagram. Okay. So you are going to measure. Can I have the diagram, please? Exercise vision 3. Yeah. Actually, I should call this one vision 3. Never mind lah. Any exercise, it doesn't matter. So same thing. Those question you can do, you please do first. Right. Discuss the advantage of using computerized vision measuring system. So you need to do some research. Or you can read from your notes. Okay, on a coordinate measuring machine. Okay, and fill in this. Then question number 2, sketch. Right, the step carry out to align the part coordinate system. So you need to understand what do you mean by part coordinate system. Part coordinate system, you refer to your notes, practical notes. There is a diagram. Okay, or this exercise here. There's a drawing, right? Okay, to tell you where's the part coordinate system. So please use this line for alignment, datum A, and please use whole A here, but not be very clear lah. Okay, actually by right the diagram to tell you that this is the part coordinate system. Your part coordinate system will be here. X0, Y0, Z0 is here. Okay, any question? And alignment is datum A axis here. Okay, so what you have to do is to mount your workpiece, okay, exactly in the middle here. The best is use a solution, alcohol or what. Clear? Then use a blue tack. Your blue tack is just a very small little piece. Okay. And press the blue tack such that it just hold at the edge, below the edge. Clear? Below the edge. As a support, that's all. Okay. So that you will not vibrate when you move the job, move the table. Can see, do not place the blue tack below, because this is the datum, right? Okay, so the datum surface is bottom. So whole workpiece must be against the datum plane here. The datum plane is this. Clear? So if you put blue tack, then your job is inclined, right? So your job will not be perpendicular to the z-axis. So these are things that as an engineer in aerospace, you are measuring aerospace part, okay, such as this. This could be a very thin part of your aerospace component. Okay, so anything that is thin, right, such as your washer or whatever that you want to measure, okay, you need to use this machine, vision, right, non-contact one. Okay. So first thing is to on the machine, on the computer system here. Yeah, there's a button here on. Then on the power here. Okay, so these are dimensions that you are going to measure. First of all, the job mounted will be not aligned with the axis of the machine. So we are going to make use of the machine software to measure the features and align the features align with perpendicular to the z-axis and align with the x-axis and set the datum pole to 0. So that's what we call part coordinate system. Align with the machine coordinate system. Any question? Don't sit on the table, please sit on a chair. Bring a chair and sit down. Okay, the speed is here. Okay, so use a full speed. Use a full speed. The joystick is here, right? X-axis will be this way, X. Alright. Okay. So this is called the gantry type, a fixed gantry type. This is a fixed gantry type. Okay. And then your camera is right inside. Okay. You can see the camera. Later on you can see your. Then yeah. Then the z-axis is inside here. Okay. 250. 250. Yeah? This is the y-axis 400. X is 400. Okay, so this is x. Z is here. Z. Okay. X. Y. So every year we calibrate the machine. Make sure that the x is perpendicular to the table. The table is already adjusted perpendicular to the axis of the z. Okay, so we presume that this job is perfect. Flatness and also parallelism is very good. So therefore, when you place this job against this surface, the whole surface here is perpendicular. All the features, I don't know. Okay, we presume that this is perfectly perpendicular. Otherwise, if you slanted, then whatever you measure is all wrong. Okay, and hopefully that when we manufacture, all this hole is perpendicular to all the axis of all these features is perpendicular to the datum. Then it will be perfect, right? That is assumption, okay? But we need to actually measure, align, okay? With 4 point. Okay, but we are not going to do that. Okay, I'm going to use this hole, first hole, measure this hole, set this hole to 0, x, y, z to 0, and then measure this hole, okay? And using alignment axis to align such that this is whatever catcher is aligned with the axis of the machine. Okay, any question? Okay, and after alignment, then you start to measure all these, all the features here. As you measure properly, you get this diameter already. Okay, you can record down A. You can I call this one is A1. This one is A2. Okay, but I want you to record A1 diameter. I want you to measure diameter B. Okay, I want you to measure diameter D. Diameter D is an imaginary diameter calculated using all these diameter. In the notes I say measure 3 only. You measure all the 5 holes. You call this one as C1. After measuring C1, you record down. Clear? What is the diameter of C1 and compare whether within specification or out of the specification. And you measure all these holes C2, C3, C4, C5. Okay? And calculate the imaginary diameter, which is called PCD, by recording all these 5 holes. Okay? And call the circle command. Okay? Record all these 5 holes. Okay? You can analyze the diameter D. Okay, if it is circle, use a circle command. Very simple. Okay, so the software is here. Where is the software? Here. This one, you can see X, Y, Z, X, Y, Z symbol here. QV pack. QV is a quick vision. This machine is called vision measuring system. It's a form of a coordinate measuring machine by using a camera, a vision, a non-contact one. And the manufacturer is called Mitutoyo. So you can go to Mitutoyo website to download the specification of this machine. Then understand about, read up the catalog. Okay, then you say okay. After then you will initialize the x-axis. You can see now the x, y is 0. X, y, z is 0. Okay. So you say okay, it will initialize for you. Alright, the Z you move up and down, the X you initialize, and the Y you initialized. Okay, any question? You can download the, it'll take about a few minutes. Then you got so many other window, right? Graphical window. When you measure, you can see a graphical window, but no need to see lah. Just close it. Then you got this window here, right? No need to see. Just close it. Okay, so now you can see after initializing, the X is 0, the Y is 400. Okay, so the 0 of the Y is right inside. Clear? And then the Z is moved to Z 250, which is up there. Okay, so the Z0 is below. So be careful. Okay, so first thing what you have to do is to bring the camera down, okay, and near to the hole here. Okay, so how to do that? X is here, this X. Okay, then Y. Then the Z is this rotate. Okay, you want it to be down, rotate anti-clockwise, you'll come down. So you don't know where you are right now, so on the light source. There are many light sources here. Okay, one light source is the shadow which is coming from the bottom. We call stage light. Okay, and then we want to look at the surface so that you can see the whole surface. The light source come from the bottom, the top. Okay, and then you have other segment type of lighting. Okay, we have also reflected. Okay, so light source can be front, okay, back, left and right. Okay, or you can ring them together. We call ring light. Okay, we call back ring light, front ring light. Okay, and then left ring light. Okay, and right ring light, but you can on all together, okay, and form gang it up, okay, and then you can adjust the reflector also. Okay, so the light source where here, stage control is here, light source is here, you can see stage light, coaxial light is the top light. Okay, the ring light, all the ring light here. Okay, any question? Then you can have the ring position, right? Position of the ring. So you can on now this light source. Easier, put 100%. Can see the light? Then you can move now to the position that you want. You can see, right? Without the light, it's very difficult. Okay, the coaxial light we must on. Then now you can see already, right? Okay, that at 0 degree, a hole got 0 degree, right? 90 degree, 180 degree, 270 degree. Adjust the light source in the middle at the then you can off this light source. You can on the stage light. Can see? Now you can see a bit of image. Then you can adjust until it is sharp. At 0 degree, you can see it's sharp. Any question? So then you can call the command now, or you can adjust the magnification. It's too big, right? You can see the eye is too big. You can reduce the magnification as low as you can. Okay, you can see you see more arc. All right, and then you can see it's sharper now. Okay. And you can do the auto focusing here. Auto focusing, you can. So this is home. Please don't use this. Re-zero. This is the last thing that you have to do before you shut down the machine. You make sure that you re-zero. Don't use home. Home means currently you set this to home position. Please don't do that. Okay. Re-zero is the command. So you can re-zero. Okay. You'll go back to the 0 point, the home position, and then you can shut down. At the end of the day, then you use this command. Okay. Then this is the auto focusing. Okay, you use auto focusing. You can focus along the bright and dark side. Along the bright and dark side, along this axis here, bright and dark, right? Then you can adjust the focusing, right? Okay, you dark and dark you can't see. Okay, so you got y-axis. If you use y-axis, is along here, which is wrong. You must use the x-axis. Okay, x-axis focusing. So now you can see a very sharp, and then you can see a shadow here, a bit of shadow. You can increase the light source until the shadow this way. Then that is the correct image for measurement. You cannot be too dark. Okay, you can see. Then you cannot pick the correct point. Okay. You cannot be too bright. Can see? So too bright, it become bigger. Can see? Bigger. So it must be just nice, right? Until okay, you can see a shadow here. From the shadow, you can see you adjust until the shadow gone. That is the way. It's just like your camera. This is just exactly like your camera when you take a photograph. Then you can now call the command. Command is your point, line, circle. Okay, so if you want to measure circle, you can call circle. Okay. Inside here, you can also adjust the contrast. The area contrast. You can also have autofocus. Okay. So this is additional command which I think not necessary. Okay. And then we want to measure this pick point here now. Okay. So to pick point, you can pick point by point. Point command. Rectangle command. Circle. If you can see the whole circle, use a circle command. If you see the arc, you can use the arc. This is your arc, right? Yeah. Then you can use the arc. Then where to ditch to collect the point at the target here. Okay, can see. Okay, so I don't like to use the. Okay, I don't like to use this. Okay, I don't like to use this. I like to use the box. Box. Okay, can see. So how many points? 7 points. If you want to use the arc, also can. Up to you. Right? Yes. 665 point now. Is this okay? Then you can move to 90 degree. 90 degree of the hole here. Okay, so your image you cannot put here. Clear? And pick the point. No. You make sure the image is at the center. The hairline is here, right? Okay. Hairline is here. Your target line. Then you pick a point here. Any question? If you pick not at the axis, not at the target, what will happen? Not accurate. Okay, always pick point at the target. It's just a rifle, right? When you aim, you must use your target line as a datum, right, to shoot. Okay, so same thing here. All right. Otherwise, you cannot hit the target, right? As close as you can now. Then 270 degree here. So you can see what I measure is quite easy, right? But I can tell you, when you operate here, it will be different story. It's just the first time when you drive a car. Okay, you press the accelerator to control the speed, right? So same thing here. Okay, you'll find that you move only, disappear. Your image disappear. The reason is because you don't know how to control properly. Okay, you should control with high speed. This one don't put to 0. You will never be able to move. Clear? Or you put 50, then your scale is almost 0. After your scale will depend on high speed. Clear? Must measure using high speed. Am I very clear? Okay, then after collecting the point, you say okay. You will construct a circle for you. Okay, call this one A1. Please follow the instruction, A1. Okay, and then you can output the diameter as required on this table. Okay, this table you have to measure diameter right? You that is A. Then you output, output is here. So this radius is wrong. Okay, output the X, Y, Z is wrong. Okay, because it's not meaningful, because now it's not set to 0 yet. Okay, you output the diameter will be good. All right, 8.544. So you can record down also. A1, you output to here. Then you can record down. Then you can analyze later on. Okay, and then remark is accepted, rejected, oversized, undersized, within specification or whatever. So that's the remark. Okay, what piece number is stated here? Okay, any question? A, then you can set A to 0, A1 to 0. How to set? So currently, listen here. Currently, you can see X is not 0, Y is not 0. You can see Z is not 0. You need to set to 0. The center point of this hole to 0. How to set here? Origin. Okay. Then make sure you click X0, Y0, Z0. So I say okay. You can see now it's set X to 0. Okay. And then Y is negative, right? You are in from here 0 down, right? This is negative, half the radius. Okay. And then you can see just now was machine coordinates is MCS. Sorry, MCS, but now you change to PCS. Just now I forget to show you here. So this is PCS, means part coordinate system now. The machine now is set to the part coordinate system, which is this hole here. Okay, any question? But it's not aligned yet. Okay, if you move to the next hole, looks like you are not very uneasy now. Okay, so if I move to here, if this is aligned properly at 270 degree here, 270 degrees, somewhere around here, right? This hole. You can see this one should be half the radius, almost parallel, but it's not parallel. Okay, half the radius away from this hole is 8.5, half of it is 4.2, right? 4.2, but it's now 0.2 out of the misalignment. I put it quite parallel. Okay, so now you have to align. Measure this hole and align. So when you measure this hole, the same thing. Call circle command. Circle command is this. At 0 degree, circle command, use the arc. Okay, can see. Then 90 degree. Then 180 degree. Okay, and then over here 270 degree. Then you say okay. Okay, so this is call this one as A2. Okay, so A2 is this. No need to output anything. Don't have to output. So you just cancel. Make sure no output. Result no need. Then you say okay. Any question? If you any question, you need to ask me. Okay, so you can see now at 270 degree of the hole, this one should be half the diameter, right? Which is okay, 4.3, right? Alignment is here. Next align axis. Okay, make sure you pick A2. Okay, then you can see this reading change. Okay, and this reading a bit change also. Should be about 88. Can see 4.25 now. Okay, any question? Alignment. We call this one as a part alignment. That means we align this part parallel to the axis of the X, Y coordinate system of the machine. Okay, so we call that as alignment. Any question? So once you align, you can start to measure lah. Measure B, measure C, okay, and so on. Measure the square hole. This square hole, how to measure? Anyone? How to measure G? line. Okay, so you want to measure G. First of all, you use the line here. Okay, maybe I just try. Okay, we still have half an hour. The other exercise I think should be quite fast. So I will move to G. It's on the coaxial line. Okay, we are here now. The square hole is here. Okay, maybe I just measure C to show you. C is this diameter here. Can see? So it's a full circle, right? Okay, so for full circle, you off this first. For full circle, use a circle command here. Circle, circle. Don't use arc. Use circle. Okay, and then just ditch here at the cross target point here. Okay, you can see you pick up all the point here. Can see? Then you say okay. Right, and then this is C. C1. Okay, then you're supposed to output right C1. C1 here. Okay, then you can output the diameter. Okay, 3.493. You can also key in the nominal. Okay, so maybe the other group I didn't show. Okay, so the tolerance is here, right? Can see? Over here you can now key in. Use nominal, right, to analyze. Use nominal. Click here. Then tolerance. Nominal is in this case you key in the nominal. Nominal is 3.5. 3.5. Okay, tolerance you can key in the tolerance. Add tolerance. Okay, so you give a label, maybe C. C1. Give a name, any name. C. And the tolerance of C is here. Okay, plus 0.05 minus 0.05. So there's a tolerance. Then say okay. Any question? How to key in the nominal and analyze? Then you say okay. Then you tell you pass or fail. Yeah, any problem? Yeah. Okay. Any problem? How to key in the nominal? Yeah. If you want to key in, you can analyze. So that easy for you. Then that means pass means within the specification, right? Okay. Next is to measure the G. So how to measure the G? The G will be here. This line, right? This side, this edge of it. Okay. The edge of this line is here. So this side here, you measure a line. Okay. Do not pick point at the corner. Okay. Line command is this. Okay. Use a box tool. Then you create a line here, as many points as you can. Okay, move upwards to create a positive vector. Now the line, this is a line, right? You cannot measure a line from the bottom to the top. Okay, pick point this way, wrong. You must pick point this way, so that this line become 90 degree. But if you pick point this way, this line become 270 degree. Okay, so likewise horizontal line here, right? This is a horizontal line. Am I right? So if you pick point 1, 2, 3, 4 this direction, this become 180 degree. If you pick point this way, it become positive direction. Okay, it becomes 0 degree. Is this clear? Yes. So this is important. Okay. So line got vector. There's a direction. So you must pick the correct direction. Okay, so this is enough example. Okay, so this is I call it GL because it's the feature is G. All right, and I measure using a line. You don't have to output, because over here is G, right? G is this width here, right? I already measured this side here a line. Now I'm going to measure this side a point, not line. Line and line cannot calculate distance. Clear? You must use point. So okay, a line is created. Okay, then you go opposite side here. go to the bottom. Always put a point in the correct direction. Use point now, point. Okay, and then you can pick as many points as you can using a box tool. It'll give you an average point. Although the point command, you can pick as many points as you want. Okay, so you'll calculate an average point for you. Okay, so okay, then you give you a point right at approximately the first point and the last point. In the middle, they create an average point for you. Okay, so I call that GP, GP, because you have feature G and I use a point to measure, so GP. Give any name as you like. Okay, then after distance, here distance. Okay, so GP and GL, can see it will give you a distance 10.03. So you can output this. Call this one as G. Any question? Line and point to give you the width, to measure the width. Right. Likewise here, it's the same thing. The width, right? Okay. So use line and point. Line this side, point this side. Pick the correct direction. Here the same thing. Line and point. Will give you the J, and this line and this line you can compute midline. Midline is here. It's midline. Okay, it'll give you an imaginary line in the middle, and it'll give you a K. Any question? And over here is radius. This is arc, right? So use a circle command, but it's 180-degree arc. So when you pick point, you pick along the arc. Okay, then you output the radius. Over here, another arc. You need to measure another arc. Okay, use circle to. It's a circle, right? A part of circle. So use a circle command, but you measure using as many points as possible to form this diameter, imaginary diameter. Okay, and then distance between these two will give you F. You need to use a distance. Okay, I think that's about this exercise. Demonstration about this exercise.